Now, what is an algebraic identity? An algebraic identity is an algebraic equation which is true for any value of the variables. It means an identity is satisfied by any value of the variables. Let us understand this. Now, what is an algebraic identity? Please remember, an algebraic identity is also an algebraic equation. But the difference here is that an algebraic identity is satisfied by any value of the variables. That is the difference here. Therefore, we can say an algebraic identity is an algebraic equation which is satisfied by any value of the variables. Let us take an example. If you take here a plus b whole to square is equal to a square plus 2ab plus b square, put any value to a and b, LHS becomes equal to RHS. Therefore, this is an identity, or rather an algebraic identity. Remember that. There are many identities which we have to remember, which we have to know, because they are very much useful in calculations. Now let us just see what are the identities here. We have got 14 different identities listed here. We have got x plus a into x plus b is equal to x square plus a plus bx plus ab. A plus b whole to square is a square plus 2ab plus b square. A minus b whole to square is a square minus 2ab plus b square. A square minus b square is equal to a plus b into a minus b. A plus b plus c whole to square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2c. And a plus b whole to cube is a cube plus 3a square b plus 3ab square plus b cube. Then a minus b whole to cube is a cube minus 3a square b plus 3ab square minus b cube. A cube plus b cube is equal to a plus b in the bracket a square minus ab plus b square. A cube minus b cube is equal to a minus b in the bracket a square plus ab plus b square. A cube plus b cube plus q minus 3abc is equal to a plus b plus c in the bracket a square plus b square plus c square minus ab minus bc minus ca. And we have the product of three what you call algebraic expressions here: x plus a, x plus b, x plus c. The first variable is x, and the second term a, b, c are different, and the identity is x cube plus a plus b plus c, x square plus ab plus bc plus ca, x plus abc. A cube plus b cube is equal to a plus b whole to cube minus 3ab in the bracket a plus b. A cube minus b cube is equal to a minus b whole to cube plus 3ab in the bracket a minus b. A cube plus b cube plus c cube is equal to 0 if a plus b plus c equal to 0. Very, very important identities, and these identities you have to remember, and this is the basis. Very important identities, whether it is algebra, trigonometry, in mathematics, very, very useful identities. They have their own applications. We'll be studying them later. Now the identities can be proved. We can prove these identities by simplifying LHS and showing that it is equal to RHS. Remember, an identity can be proved by showing that LHS is equal to RHS. So we can show or begin from LHS and show that it is equal to RHS. So that is how we prove the identities. Now let me take one example here. Now if I want to prove this identity, a plus b whole to square is equal to a square plus 2ab plus b square, what I will do is take LHS. LHS is a plus b whole to square. A plus b whole to square is nothing but multiplying a plus b twice. Apply the distributive property. Take a and take a plus b whole here, plus b, a plus b again. Then open the bracket. That is, apply the distributive property twice. A is a square. A plus ab plus b square. That is a square ab plus ab is 2ab. It is a square plus 2ab a square plus 2ab plus b square, and that is equal to RHS. So therefore the identity a plus b square is equal to a square plus 2ab plus b square is proved. So this is how we can prove the identities. All these identities can be proved. Remember that. Now coming to the next important point, that is application of identities. We can use the identities for solving examples. Now let us take, for example, we want to multiply 102 into 103. We can multiply them directly. We can take the product of them. But here we want to apply algebraic identities. So let us see how to apply. Now 102 can be written as 100 plus 2. 103 can be written as 100 plus 3. Now this is x is same here, 100, a and b are different. It is x plus a, x plus b. We know that x plus a into x plus b is x square plus a plus b into x plus ab. That means here x is 100, a is 2 and b is 3. Now use the identity, that is the right part of this, and apply. So now x square is 100 square. A plus b is 2 plus 3, x is 100, and product ab is 2 into 3. Now 100 square is 10,000, 2 plus 3 is 5 into 100 is 500, 3 into 2 is 6. Therefore, when we add that, we get 10,506. So that is how we can use identities to find the product of bigger numbers. Now let us talk about one more example, that is 99 square. 99 square can be found out by taking a product by 99 into 99, but here we want to apply the identity, so therefore 99 can be written as 100 minus 1 whole is to square. 100 minus 1 whole is to square is a minus b whole is to square, so a minus b whole is to square is a square minus 2ab plus b square. Here a is 100 and b is 1, so take the right hand side. A square is 100 square, minus 2ab is minus 2 into 100 into 1, and b square is 1 square, so 100 square is 10,000, minus 2 into 100 is minus 200, and plus 1 square, so 10,000 plus 1 is 10,001. Subtract 200 from that, we get 9,801. So that is how we can use an identity to solve or find the product of higher or bigger numbers. Now let us take one more example. Now if you want to find the product of three numbers, 103 into 102 into 98. Now we want to find this product. We can find out the product directly by multiplying them, but here we want to use an identity, and to decide which identity, since there are three terms, the identity which can be used is x plus a into x plus b into x plus c, and you know that x plus a into x plus c, x plus a into x plus b into x plus c is x cube plus a plus b plus c whole x square plus ab plus bc plus a into x plus abc. Now let us convert these numbers in the form x plus a, x plus b, x plus c, that is 103 is 100 plus 3, 102 is 100 plus 2, 98 is 100 minus 2. Now here x is 100, a is 3, b is 2, and c is minus 2. So therefore applying the right hand side here, we have got x cube, that is 100 cube, plus a plus b plus c, that means 3 plus 2 minus 2 into b square, that is 100 square. Then we have got ab is 3 into 2 6, then bc plus 2 into minus 2 is minus 4, and CA, that is minus 2 into 3 is minus 6, into x, that is 100, and ABC 3 into 2 6, 6 into minus 2 is minus 12. Now 100 cube is as you know 1 followed by 6 zeros because there is cube. Then we have got plus 2 minus 2 cancels here, 3 multiplied by 100 square is 10,000. Then here minus 6 plus 6 cancels, minus 4 into 100 becomes minus 400, and plus into minus is minus 12. Now add the positive values. We have got that is multiply this, that is 30,000, then minus 412. So add these two positive values, we get 103 followed by 4 zeros, minus 412, subtracted, we get the value 1029588. So remember, so that is how we find out the product of three numbers. Okay, three numbers using an identity. This is a very important identity which we can use for solving or finding the product of numbers. Now this is a very important study here again, that is called as the remainder theorem. Remember, remainder theorem. So let us see what it is. If p of x is a polynomial of degree greater than 1 or equal to 1, if px or that is divided by a binomial x minus a, then the remainder is p of a. Please understand this. There is a polynomial p of x, and it is of degree greater than 1. And if it is divided by a binomial x minus a, then the remainder is p of a. That means in the polynomial p of x, wherever x is there, put a. If it is x minus a, put a. If it is x plus a, put minus a. So that is what is the method. Now let us see what it says. Now the remainder is the value of when x is, that means we have p of y is equal to y raised to 4 minus 3y square plus 2y plus 1, and gy, that is the y minus 1 is the binomial. So now if y minus is the binomial, now we have to find the remainder, that is rx. Now what we do, wherever y is there, put 1, because since it is minus, I have to put a, that is 1. So p of 1 will be 1 raised to 4 minus 3 1 square plus 2 into 1 plus 1. 1 raised to 4 is 1, minus 3 1 square is 1, minus 3 into 1 is 3, plus 2 plus 1. If you add this, we get 4 minus 3, and the remainder is 1. So please remember that. So that means the remainder theorem is a very important theorem which can be used to divide a polynomial by a binomial of the form x minus a, so that the remainder will be p of a. Now let us see whether this is correct by long division method. So let us go by long division method. The same what you call polynomial y raised to 4 minus 3y square plus 2y plus 1 is divided by y minus 1. Now I have to eliminate the first term here, so I will multiply by y cube. Y cube into y becomes y raised to 4, and minus 1 into y cube becomes minus y cube. Subtracted, this will cancel. Minus 3y square there is so y cube, there is no y cube term in this, so bring y cube as it is, take minus 3y square as the second term. Now we have to eliminate y cube, multiply y with y square into y becomes y cube, and minus 1 into y square becomes minus y square, so y cube minus y cube will cancel, minus 3y square plus y square becomes minus 2y square, and bring this 2y down here. Then we have to eliminate 2y square, so multiply y by minus 2y into y becomes minus 2y square, and minus 1 into y becomes minus 2y, so minus 2y square plus 2y square will cancel, and plus 2y minus 2 will cancel, and the 1 is brought down, and 1 is the remainder. So that means the remainder theorem is an excellent theorem wherein we can find out the remainder when a polynomial is divided by binomial of the form x minus a. Remember that. So that is what is the remainder theorem, a very important theorem. And remember all that we have discussed in this part and the first part of simple equations, very important as far as mathematics is concerned. Learn them, revise them, remember the basics, remember the properties, take a book, write down everything in that book for your future reference. Thank you.